This is the answer to homework 6, question 2. So the question gives the function f of xy is equal to b, where x squared plus y squared is less than or equal to 1, or 0 otherwise. And so the first part of the question asks us to find b that to make the function a valid joint density function. So similar to question 1, we set up the double integral for f of xy dx dy, and this should be equal to 1. But because we can see that x squared plus y squared is a circle, we can take a shortcut and just calculate the area of said circle. And we know the radius is 1, which means the area is just equal to pi 1 squared, or pi. So then when we calculate that out, we have b times pi is equal to 1, or b is equal to 1 over pi. So the next part of the question asks us to calculate a few different expectations. So we have expectation of x given y, the expectation of x, so we have y as a value, and then we have y as a variable, and the expectation of y, and then kind of the other way around, you have y given x, y given the variable x, and then expectation of xy. So I got my bounds by kind of just calculating it from the inequality, or from the equality, I mean. So we have x varying from negative the root of 1 minus y squared to positive root 1 minus y squared, and y varying from negative root 1 minus x squared to positive 1 minus x squared. And so when we set up the integral, we can see that so we're multiplying, for the expectation of x, we just multiply the function by x, where in this case the function is 1, so it's 1 times x, but we know that x is an odd function, and we have symmetry on both sides of our boundaries, which means that that integral is just going to be equal to 0, so e of x is equal to 0. And so because the expectation of x is equal to 0, that kind of we can kind of infer that the expected x for all y is also going to be 0, which means e of x given y is equal to 0, and e of x given a value of y is equal to 0. And when we look to e of y, it's kind of the same situation because of the symmetry of x squared plus y squared. So therefore, e of y is equal to 0, and consequently, because for all of y it's equal to 0, then e of y given x, value x is equal to 0, and e of y given the variable x is equal to 0 also. So that just leaves us with expectation of xy, and so here we're setting up the integral. We're multiplying 1 by both x and y this time, and when you segment the integral out, you end up with an odd function again, because x is an odd function and y is an odd function, which means this integral is going to be equal to 0. And so that kind of leads into the final part of the question, which asks us to prove or disprove that x squared and y squared, prove that x and y are uncorrelated. And so because e of xy is equal to 0, we can see that e of x of e of y given x is also equal to 0, which implies that e of x times e of y is equal to 0. And since e of xy is equal to e of x times e of y, that means that x and y are uncorrelated.